Okay, in this quick video, we're just going to talk about different types of errors that you can get in computer programming. We definitely came across these errors last year in the grade 11 course, but we may not have actually had a formal note on types of errors and what they're called. So I've created a simple class here called errors, and it's just outlines three types of errors that you should know about. So the most common and probably the best error that you can get because it's the easiest to fix, these are called syntax errors. So this is any error with the grammar or the language of the code. So like you spelled something wrong or you have a missing semicolon. With these types of errors, the program will not compile or run. So as a quick example here, like if I remove this A, so if I was typing really fast and I forgot to put an A there, then when I compile, it says that I have an error. And BlueJ does its best to try and tell you what the error is. Sometimes this isn't great. Sometimes it doesn't give you a lot of useful information. Or if I forget a semicolon, let's say right here, and I compile. All right, so that's a good notification there. It's telling you that the semicolon is expected. Okay, or even something like if you deleted this assignment operator. Or the equal sign. So if you compile that, then okay. So here's an example where the message here doesn't really jive with the actual error. So we do have a semicolon here. So basically, you have to look at the line and try and figure out what might be missing. So we do need an assignment operator. Okay. All right. So those are called syntax errors. They're pretty common. You're going to get a lot of them, and they're just simple mistakes. You just basically have to figure out what you spelt wrong or what you missed. Okay, the next type of error is called a semantics or a logical error. So these ones are actually pretty tough to debug and to figure out where you went wrong, because the program actually works. It compiles and it runs, but there's an error with the output. And I'll show you an example of this. Some of you may have had a semantics error in your sphere volume question. So the first time you ran it, you may have got an unexpected outcome, like the wrong answer. And it's probably because you did 4 divided by 3 as two integers. Instead of 4.0 divided by 3, which keeps the decimal in that division. So some of you may have got that in last day's program. But here's another example. I've written a quick program here that asks the user to enter x1, y1, x2, y2, and then I'm going to calculate the slope. Okay, rise over run. And then I'm going to display the slope. So everything kind of looks okay here. And when I compile it and run it. Okay, so I'm going to enter 0, 0. Now I am going to enter, let's say the x2 is 1. And my y2 is 2. Okay, so if you can picture this, imagine one of your points is at 0, 0. So think about math class and your axes. So one point is at the origin 0, 0, and you have another point at 1, 2. Actually, I'm going to change this. Yeah, I'm going to do a different example here. I'm going to force close this window, and let's stop the program from running. Okay, I'm going to give just a different example. So 0, 0 and 2, 1 is what I meant. Okay, so you have a point at 0, 0, and then you have another point at 2, 1. So the rise is 1 and the run is 2. So from math class, the slope should be 0.5. Okay, the slope of this line segment between these two coordinates should be 0.5. But if I press enter, it tells me 0.0. So the program runs and it gives me an output. It doesn't crash, but the output is wrong. And in large applications where you have a lot going on, these semantics errors are sometimes hard to find. So it's really important to test your program and exhaust every single possibility. And even when you do find the error, it's sometimes hard to fix the code. So the problem here, maybe you have figured this out, is that this is an int and this is an int. See, I've used int variables for x1, y1, x2, y2. So we have an int divided by an int, and it's going to throw away the decimal when it does that division. Yet, even though this says double, remember that Java does the calculation first. So it does the right-hand side of the equal sign first, and then it puts that value into this variable. So there's two ways you could fix this. You could either make all of these double variables, okay, and that has the added benefit where the user can enter decimal values now for these. Or if you did want to restrict these to ints, I just change these back to ints. So if it's a requirement of the program that these must be ints, what you could do is just cast the numerator to a double. So you could do that either by multiplying by 1.0, or you can write the word double in parentheses, and that will basically temporarily convert this int into a double value. All right, so now it's going to keep the decimal, and when I compile and run it, 0, 0, 2, 1, now I get the correct answer, 0.5. Okay, so that's an example of a semantics error, or also called a logical error. All right, and then the other example would be a runtime error. So this is where your program compiles, so there's nothing wrong with the syntax or the language, but it's going to crash during runtime. So if let me explain the formula here. If you look at the slope formula, if the denominator is 0, then that means my program is going to crash. Actually, I'm pausing because it might give me infinity. So let's try that. Let's try and make the denominator 0. Now, how do I make that 0? Well, if both x2 and x1 were the same number, so if I had like 5 and 5, then this denominator would be 0. So let's try and make that happen. So I'm going to run this program. And x1 I'm going to make 5, and y1 I'll do 2, or 21, doesn't matter. And then x2 I'm also going to make 5, and then I'm going to make y2 13. So now my x's are the same, and if you think of this mathematically, like think of this as two coordinates, they both have the same x value. So that means the 2 points are right on top of each other. Okay, so it forms a vertical line, and we should know that the slope of a vertical line is undefined. So let's see what happens. Yeah, okay. So this is a bad example here. This is not a runtime error. It actually worked. It's just giving me negative infinity as my slope, which again I don't like. I wish it had said undefined. But if I take this back out, this double value. So if I just temporarily take out that casting just to show you a runtime error. So I'm going to do this once again. I'm going to put 5, 8, and 5, 2. Now watch what happens. Okay, I pressed enter and this thing stopped working. It didn't print my answer, and it takes me back to the code and it says you have a division by 0. So this is probably the most common runtime error that you can get. Yeah, this is a case where I'm dividing by 2 ints and the denominator is a 0. So that's going to cause a runtime error. Another example of a runtime error is if, okay, I compile it, everything's fine. I run it, everything's fine. And then all of a sudden I put like dog as x1. That's going to interrupt my output, and it's going to take me back to the code and say, in this case, input mismatch exception. So so that is an error because I'm using the next int command. So I have to enter an integer for this to work. Okay, so there's another example of a runtime error. So you should know the 3 of them. Last thing I'll say here is that in Java and C++, we often call these exceptions. So another word for error would be also an exception. Okay. Some of you might know about try and catch statements, things that will prevent runtime errors. They're kind of like if statements. So if it catches a runtime error, it handles it nicely and it prints a nice message instead of crashing. I'm not going to get into that, and we don't need to know it for this course or the AP exam. So I'll let you investigate try catch statements if you'd like to. But yeah, you should know these three types of errors. Okay, thanks for watching.